Cloud Engineering for Beginners. Could I use AWS Lambda for the backend of my website? And is that even better than just using a regular computer? I set up this dummy operation on my desktop computer. I'll call this my local server. When you make a request, the server just does some random calculations and spits back a random word. Now when we have these 6 boxes, that simulates 6 people making requests to the backend at one time. All boxes start off as red. When I press a button, the requests are made all at the same time, and each box turns green when the request is successful. Now we're starting to scale up this operation, and that simulates more people visiting your website at the same time. Now see how all the boxes aren't turning green at the same time. We're starting to see my local server, my desktop computer, start to slow down. Now we'll see side by side my local server versus AWS Lambda, which you can think of as a bunch of virtual machines in the cloud. We're at 500 requests, and AWS Lambda with the same code is the clear winner. Let's go bigger, 2,000. Now there's this other interesting thing on the Lambda side that we'll see, which is almost about half of the requests get filled all at once. This is about 1,000. What I didn't tell you is there's this other AWS component called API Gateway, which allows you to set the limits of how many requests can be made at the same time. And the purpose of that is to protect your system from unexpected traffic, so your computers don't blow up. API Gateway, Lambda, what are these things? We'll get into that. But here, the cloud backend is the clear winner, scalable, robust, and let's use that for our project. In today's project, we'll make this AI-powered quiz generator. And what's that? Let's say that you're preparing for a cloud certification and you need to test yourself. So you go onto a website and you copy a body of text. You paste it in here, choose how many questions you want, and then generate. Now you have a quiz. You choose your answers and you click check, and then it shows you what are the correct answers and how many you got right. And because this is AI powered, you can put any body of text in there. You're studying for your real estate license. You're studying for an engineering test. This is a cloud project, yes, but also it's a pretty cool AI, also known as LLM project. And that's because I wanted to show you something new, something besides an AI chatbot, which we're getting overloaded with today. Here's another thing we can do with LLMs that's not a chatbot, but I also want to know in the comments, what other ideas do you have? So let's build this thing. And also, I left all this code on my GitHub, so you can take a look at everything. We can split up the code into mainly 3 parts. Number 1, the backend code. What is the backend going to do? And in this case, we're going to use LLMs. Number 2, that backend logic has to be run somewhere. It needs to run in a virtual machine on the cloud. So number 2, we need to build cloud infrastructure. 1 and 2 together, that makes up our backend API. And number 3, we'll build a static front end that can call that backend API. Part 1, the backend code. We're going to use Python, and we need to get into prompt engineering. Let's all get on the same page first. I think most of us have used ChatGPT, but in case you haven't, it looks like this. The user says something, and then the AI says something, and then you kind of take turns. User, AI, and it seems like the AI remembers everything that you said on that page. Now, a large language model, what is that? I want you to think of an LLM as an autocompleter. It's a really, really good autocompleter, but I still want you to think of it as autocomplete because what goes in is just text, and what comes out is the next predicted text. So ChatGPT has some kind of instruction, probably you're an AI chatbot, and then the user says something, and then all this together, this big blob of text, that's what gets put into the LLM. Because you already told it it's an AI chatbot, then the LLM can predict, okay, I guess the next sequence has to be AI says something. Behind the scenes, the AI isn't actually memorizing anything. What happens is this output gets appended to this bigger blob of text, and then this whole bigger blob of text, that's what goes in the next time. This is not only ChatGPT, but a lot of chatbots from different companies will use this strategy. Okay, so now you have an idea of how the LLMs work. Let's write up our own prompts. Here's an example. Write me a summary of this context. And then I'm going to make a new line and then context. And then just notice how the format that I laid out right here, it kind of mirrors that format that we saw up here. Then the next thing to think about is, what do you want your output to look like? An LLM can produce an infinite amount of different formats. So we need to be specific. We can do it like this. Create me a website based on this content and with this format. And the format, I'm going to give it some sample HTML code. Then the output of this LLM prompt should also be HTML code. So if you get the output of your LLM to be in a very predictable format, then it's not just chatbots anymore. We can use it to do other things. Maybe we want to link it together with other LLM prompts, or maybe we want to use some custom code to parse this data and do something with it. Now to the code. This is a Jupyter notebook, and if you don't know what that is, it allows you to test small snippets of Python. I'm going to install an OpenAI Python package, pip install, and then this package. If you want to run this notebook, you need an OpenAI API key. I have one, and that's how they know who to bill whenever you use their API. Now this first cell that I'm working on, I just want to test that I can make calls to the API and it gives me something back from the LLM. I just ask for a random question to verify that it gives me a response. And here we can see that it does indeed give us a response. Nice. Now let's work on our prompt. You may remember our goal is to make this quiz making AI. Someone puts in a blob of text there and then it turns it into a quiz. So my prompt is going to be something like, hey, I want you to make me a multiple choice quiz based on this content. And I want this number of questions and I want it in a specific format. Now, if you look at this prompt, look at these three things. We have the content, we have the number, and we have the example format. These are kind of like programming variables. Then I'm going to provide the variables below. But it's interesting because it's just like programming, except that you don't have to worry about syntax. The format that I want it in, I want it to have the question, and then possible answers, and then the correct answer. I give it this really specific format, and I know that down the line, I'm going to parse it with some of my own code later. Now I want to test this out and see what happens. Let's grab some code from this Wikipedia about education, and I'm going to paste it in here, and let's see. Nice, I like it. It gave me 3 questions with possible answers and the correct answer. But look at this one down here. The correct answer is not one of the choices of the possible answers. So it didn't exactly do what I wanted it to. Even if you write the best perfect prompt, this can happen sometimes with LLMs, so you have to deal with these edge cases. In this case, maybe I want to just throw out that question, or maybe I want to retry and ask the LLM again. That's it. That's the main functionality of my backend code. Basically, I'll get the number of questions, and I'll also get the content that comes from the front end. And then I call the LLM and generate these questions, which will be the questions for the quiz. If you want to look at some of the smaller details, you can take a look at my GitHub. All your Python code, you put it into a zip file. And if you have dependencies, you put it into that zip also. Real quick, how do you do that? So to install a Python package, you usually do pip install and then the name of the package. You can also install a package with this command. All it is pip install, the name of the package, and then you give it a target folder. And then the dependencies get put into that target folder. So your Python code plus all the dependencies, zip that all up, and then that zip file, I'll show you how to deploy it with your Lambda. Pause for a second because this is really cool. A lot of you are already good at Python. And so whatever you can do with Python and whatever dependencies that you already are familiar with, you can put those into a Lambda and run them in the cloud. And that's exactly what we're doing. That Python logic that you wrote, all the dependencies, all into one zip file, and I'll show you next how we put that into a Lambda. Part 2, let's talk about your cloud infrastructure. First of all, why should we use Lambda? And let's spell that out. Most of the internet works like this. You have a front end, that's your browser at home, and you also have a backend. That's maybe something connected to a company database. The front end makes requests to the backend, and that's how different things can be displayed on screen. The old way to do backend servers, you would have some computer, somebody's computer out there in the world, and it's taking all these requests. The first problem that you'll run into is what happens when thousands of people are making requests at the same time. What happens is your backend server is now backed up, so it's taking a long time. Your computer is sad. And everyone on the other end, why is my website taking so long to load? These people are sad too. Okay, but we can solve that, right? We just need more computers. So we put a load balancer, we have multiple backend servers, and then when all the requests come in, the load balancer will decide which computer gets which request. Now everyone's website loads fast again, everyone is happy. Almost everyone. There's still one main problem, can you spot it? What happens when the traffic dies down? Maybe your website is seasonal or the traffic is unpredictable in some way. Then there's going to be some times when you have no traffic, but you're still paying for all these servers. So the problem with this setup is cost. More specifically, you're paying for servers even when you're not using them. Not to worry, we can solve that problem too. In cloud engineering, there's something called this serverless architecture. Now we're getting into what we're building today. So we have an API gateway component that's going to provide an endpoint or a URL which your backend will live at. We will also have an AWS Lambda component, and this is the serverless part. This is how Lambda works. First, you set up a virtual machine and you put that zip file in there. That's the one that we just made. As traffic starts coming in, then Lambda starts spinning up new virtual machines to handle the traffic. When the traffic dies down, Lambda will shut down these virtual machines. A lot of machines when you need them, no machines when you don't, and you only pay for what you use. Now we can handle big traffic sometimes while at the same time being cost efficient. And really what this allows you to do is even as a solo developer, you can set up this infrastructure once and you'll only really have to pay for it once that traffic starts coming in. Okay, fine. I think you're on board with this plan to use AWS. But you may be worried about, isn't there going to be a big learning curve to learn all this AWS stuff? Well, my friends, not to worry, because there's infrastructure as code. What you could do is, think about it, we're trying to set up API Gateway, this one component, and AWS Lambda, that's the second component. What you could do is go onto the AWS console and through the user interface, click and set up these configurations one by one. You could do that, but we're not going to do that. That's the hard way. Instead, we'll write code that specifies, here's our app, and it's going to have this API Gateway component and a Lambda component. This code will be something like Terraform, or today we're using AWS CDK. This code is the blueprint for what will be created in your account. I set up this infrastructure code and I deployed it to my AWS account. I tested it and it works. I put that code onto GitHub. Now, whenever I want to build this project again, I can download that code and deploy it to another account. Are you see what I'm saying? You can go onto my GitHub right now and download this code and deploy the exact same AWS components that I have. Other benefits of infrastructure as code, let's say you've made improvements to your app. You've made things better. So version 2. Then you can update all these AWS accounts programmatically without having to go into them one by one. All large tech companies are doing this, or they should be doing this. So infrastructure as code, think about it like this. You do the hard work once, and then from there, it's copy and deploy. But in this case, for this project, I did the hard work once, and you just have to do copy and deploy. Now let's look at the code. I'll point out the main things so you can think about what you might want to edit. Here we have the Lambda, and we're going to tell it, hey, I want you to run on Python, and I'm going to provide you that Python zip file. API Gateway, this is going to be a REST API. With API Gateway, you can specify things like what's the maximum number of requests that can be made before we start rejecting them. And this is in number of requests per second. If you remember way in the beginning when we were doing that scaling experiment, this is what slowed down the requests on the Lambda side. You also have to specify where your front end will be located. In other words, like where are you going to host your front end? Because this line says, hey, traffic coming from this website, That's the traffic that I want to allow. And all other traffic, no. Lastly, we have this one other file where you specify your account number and then a region. What's a region? So AWS, they have these data centers all over the world. That's where the actual physical computers will be stored. When you choose a region, you're saying, I want my infrastructure, this virtual environment, I want that to live in this physical location. You can choose a data center in the US or in Asia, and the mentality is the closer you are to your customers, the faster the responses will be. That said, even if you choose someplace really far away, it's still going to be reasonably fast. To deploy these components to your account, you need to provide credentials. I've left some comments about how you can do that in here. Now, let's deploy all this to our AWS account. Run these two commands, npm run build and cdk deploy. If you get an error like this, oh right, that's because I forgot to change the account number to my real account number. Once you deploy it successfully, then we can go into your AWS account. Let's look at what we just created. So click on region and then click on CloudFormation. This item here, this is called a stack. This is everything that we just deployed. And then if we click on resources, we can see the Lambda and the API gateway component. Let's go into both the Lambda and the API gateway. So first, the Lambda. I'm going to do a test run, and I'm just going to do a GET request. I just want to see if it works, and it gives me this error. If you get this error, it's because if you remember, we used an OpenAI Python package, but I didn't yet provide the OpenAI API key. What I could have done, I could have provided my API key in my backend logic, but that's a big no-no. You don't put secrets, credentials, API keys in your code because once you share that code on GitHub, then it's over. So instead, I'll click on configuration and I can provide my environment variables here. I'll make an OpenAI API key and then put it in here. Now I can do a GET request and it turns out successful. Nice. Now we can go back and navigate to my API gateway. And I want to test this API gateway component as well. My backend code expects a message that looks like this. I'll have the number, that's the number of questions that you're going to generate, and then the content. Based on this content, I want you to make my quiz. And I'm just trying to see if I can get a successful response. The convention is that 200s are successes and 400s and 500s are something went wrong. And just to show you something going wrong, let's put in another message, something with a random variable, something that the Lambda doesn't expect. Then I get this 500 error. Recap what we did so far. So we wrote our backend logic and all the dependencies, we put that into a zip file. Then that zip file, we have some CDK code which specifies API gateway and Lambda. Then API gateway, Lambda, those instructions, plus our zip file, all of that gets deployed to our AWS account. And now all of this, that's our cloud infrastructure and the backend logic, all of that together, this makes up our REST API for the backend. The only thing that's left is now our front end needs to be able to call that backend, and we're good. Part 3, our front end. Your front end needs to know the location of your backend. So what's the URL of my backend? Go into the AWS console, go into API gateway, and find this URL. The front end I built for this project is static. That means you can host it in a lot of different places, and almost anywhere you host it, it's going to be pretty fast. And all the front end does is it has these two fields. That's the number of questions and the content. That's the blob of text. The front end will send this JSON-like message to the endpoint or the URL of the backend. The backend prepares some HTML code, and that code is going to be displayed on the front end. That's it. Pretty simple. Let's test it out. So let's pretend that we're studying for an AWS certification. And I want to test myself on Lambda. So I grab all this text about Lambda and I copy it over and paste it into my quiz maker. I press generate and I get all these questions about Lambda. And pause the video because I bet you can answer these with what we learned just now. There are a couple questions down here that are interesting to me because one of the answers is all of the above. All of the above type questions, this is something that I hadn't thought of when I was doing the prompt engineering, but it's an interesting thing that the LLM came up with on its own. When you press check, you can see the correct answers and how many you got right. And that's it. You can use this AI-powered quizmaker to test yourself on anything. This code is up on my GitHub, so check that out. And leave in the comments, what ideas do you have for AI products? And no chatbots.